it's a little out of tune. I had to get it just real close. All right, I'm gonna go with this. I'm just gonna play an F. Sorry, Bajar. Next time, G will be yours. Well, Sadik is a freelance ML engineer, focused on creating production-grade ML workflows. Since the early beginning of his career, more than a decade ago, he was fascinated by data and information management systems and has been working in this field ever since. Sadik also writes occasionally about technology, topics that are of interest to all of us. All right, so Sadik is a freelance engineer, focused on creating production-grade ML workflows. Since the early beginning of his career, more than a decade ago, he was fascinated by data and information management and has been working in this field ever since. Sadik also writes occasionally about technology. And that's what we've got. Sadik, welcome to the meetup.
Thank you. And thank you for the
Good to have
beautiful
you.
intro.
I had to go 2 times around because that first time was there was a little bit that I could have done better, and so I wanted to get it right. So hello everyone that are joining us. Hope you didn't mind that little intro. We have got something special for you today. Sadik's going to give us a presentation, and then he's going to give us a bit of a demo. So Sadik, I'm just going to pass the torch to you, man. I know you've got a lot set up, and I know you've been working hard on this. Anyone who would like to reach out to Sadik afterwards, or actually, let's just go step by step. Please throw all of your questions in the chat. Feel free to let us know if you have anything and you want us to slow down, speed up. And if there are any questions that you may have while Sadik is going through this, I'll stop him at the opportune time to ask him your question. And that's about it. If anyone in here is not in our MLOps community Slack, I highly encourage you to get in that. It's a wonderful place where all kinds of questions are getting answered. All kinds of cool stuff is going down. So I'll throw a link to that in the chat if you need it. And the other thing that I would mention, if you like this, come back. Let us know. Let us know in the chat, or if you're watching it in the future on YouTube, then give us a like. All right, Sadik, the floor is yours.
Thank you. I'll start sharing my screen. Perfect. So after the intro and the nice words from Demetrios, there is not much I can say, but let's just jump straight in on the topic. Today I'll be talking about why and how can we orchestrate Spark jobs with Kubeflow. The agenda for today is, first we'll talk about the why, then I'll introduce a bit the tools and the concepts that are used in the demo. Then how do we run Spark on Kubernetes? Then how do we run Spark on Kubeflow on Kubernetes? A few more layers and we'll be worthy of the dream levels at Inception in Leonardo DiCaprio's movie. And then we'll go on with the demo. So first of all, why do we need to do this? Can't we just submit a job into a Kubernetes cluster, wait for it to finish, and then we move on with our life? Sure, we can do that if we are running a one-off job, but usually you don't run only one job. You have to have a repetition. You need to make sure that resources are utilized as well as possible. The job finishes as soon as possible, as well as all the steps involved in it. If we think of a machine learning workflow, we usually have 3 stages. We have the pre-processing where we clean the data, we do some transformations, we calculate some features and so on. Then we do the training where one or more machine learning models are trained. And then we have the serving stage where the models trained before we make them available to the users, to the business people, or whoever the target audience might be. And then next, the data that is generated during the training feeds back into the loop to make our models more accurate, to keep our models up to date, because the initial input training data might get either old or irrelevant, and we need to improve on the feedback that we get. Right, but in reality, of course, we don't only have these 3 stages. We have feature store, we have model evaluation, we have model monitoring, and so on. But for this presentation today, we will focus only on the pre-processing stage. So, of course, in the pre-processing, we do transformation of data. In the modern days, the input data that we can use for our processing keeps growing. There are many types of sources we can use. And in order to make the processing efficient, buying the next biggest machine is not, or the next bigger machine is not always an option. Therefore, we need to distribute the load to many more machines. There have been many distribution frameworks already available. And with time, these frameworks have gotten more mature and available to a wider audience. But however, distribution is not always like we just throw all the data to our compute layer and wait till it's finished. We usually have dependencies. Some processing steps need the output of another step. Therefore, these 2 steps have to be executed sequentially. Some steps don't have such dependencies and they can be executed in parallel. Therefore, we need to be able to orchestrate the workloads and efficiently use the resources we have. But that's not enough. In order to be these transformations to be useful, we need to be able to integrate these workloads into the same infrastructure where we are running other workloads. If we don't do that, then we run into data silos. A data silo is when a group of people has access to a collection of data, but the data is not available to other interested parties. In addition, if we have this integration already included in our pipeline, then we also save time and money by not having to provision another infrastructure layer. So keeping in mind that orchestration and integration is what we need, we'll be talking a bit about tools and the concepts that we are using here. As a distribution framework for today, I'll use Spark. Basically, Spark has been around for quite a while. It is used a lot for data-intensive processing tasks. It tries to distribute the load into multiple nodes, and then once the calculations are finished, then the results are aggregated into one node, namely the driver. I won't go deep into Spark today, but however, whomever might be interested, I encourage to go through the official documentation. Next up is Kubernetes. Kubernetes is a portable and extensible container orchestration framework. It's the de facto standard in the industry today for container orchestration workloads. Basically, it makes it very easy for the user to run all sorts of workloads on it, independent on where the infrastructure is located. The Kubernetes can be running on your local machine. It can be running in your own premises or as a managed service from your favorite public cloud provider. Similarly, with Spark, Kubernetes distributes the load across multiple nodes, and then these loads are controlled by the control plane. The control plane makes sure that everything is running and is running smoothly in the cluster, and yeah, takes care also of the distribution. So now that we know Spark and Kubernetes, how do these two work together? We can either use Spark submit command to submit Spark jobs on Kubernetes. This uses the Spark Kubernetes native scheduler, or we can use Spark operator. Spark operator is an open source tool, or yeah, an open source tool provided on GitHub, and it tries to make executing Spark jobs similar to executing other workloads on top of Kubernetes. If you have the operator installed, you only need to define the Spark job in a manifest file. Then with the kubectl utility, you submit this manifest file to the cluster, and the Spark application object will be created. Next, the control plane takes care of spinning up all the drivers and executors in the cluster. Yeah, that's it about Spark on Kubernetes. Now, Kubeflow. What is Kubeflow? Kubeflow is a machine learning workflow platform for Kubernetes. Its aim is to make it as easy as possible to deploy and work with machine learning workloads. It is composed of multiple components. The training operators are some packages provided by Kubeflow to train, to run the model training on Kubernetes natively. It supports Terraform, it supports scikit-learn, also PyTorch. Maybe I'm forgetting a few, but you get the idea. We have Kubeflow serving. Kubeflow serving takes care of serving these models from the Kubeflow perspective. Supported kind of models are also scikit-learn, TensorFlow, PyTorch, ONNX, but also you can write custom wrappers and deploy them as Docker containers. We have also Cutlib. Cutlib is focused on hyperparameter tuning for deep learning cases. And then we also have Kubeflow Pipelines, which takes care of orchestrating the workloads. If we think of the first diagram with the machine learning stages, we can see that Kubeflow helps us on all these three stages. For the pre-processing, as we will see later, we can schedule and run them with Kubeflow pipelines. For the training, we can use the training operators. And for the serving stage, we can use Kubeflow serving. But for today, we'll only focus on pipelines. So what is Kubeflow Pipelines? It's an engine for orchestrating multi-step machine learning workflows. It is composed of pipelines and components. A pipeline defines all the components and their relations, as we can see here in the diagram. And a component is only one step in the workflow. The component can be a model training step, a pre-processing, or a transformation step. During the execution of the pipeline, a component is usually transformed into a pod that is executed in the cluster. But to get the idea of how to achieve our goal here, we first need to understand what are components. Components are containers or manifest files that need to be executed in the cluster. In order to run a component, there must be a component specification. The specification tells Kubeflow how can it execute this component. It defines the metadata, the interface, and the implementation for the component. If you check the Kubeflow Pipelines GitHub page, you'll see there are a lot of contributions for AWS managed services, for Azure, for GCP, for PyTorch, and for Kubernetes. And in order to achieve our goal, we will use the Kubernetes components. The Kubernetes components allow us to execute commands like kubectl apply, kubectl get, kubectl delete from the pipeline against the Kubernetes cluster. How would this work in practice? We start with the apply component. The apply component loads one manifest file. In our case, this would be a Spark application manifest file and does kubectl apply. The moment we do the apply in the Kubernetes cluster, we have one Spark object, Spark application object created, and then the job of this component is done. We move on to the next component. The next component would be the Kubernetes get component. Here we periodically poll the control plane of Kubernetes about the status of the job. If the job is still running, we continue in the loop, and once the job is in the completed state, we move on to the next step in the pipeline. The next step can be a print message, a generic component, or it can be another Spark job. Exactly. So next up, I'll move to the demo if there are no questions for now. Let me bring this up. Demetrius, are you saying something?
No, I was just going to tell you that it looks like we were clean. We don't have any questions yet. But yeah, feel free to ask us. And then also, you can send everyone that joined this right now the presentation, right? We can share the presentation with everyone. Sure. Cool. So we'll do that.
Absolutely. Right. So for the demo, we need to have a Kubernetes cluster. In my case, I'm using Minikube, but you can use whatever you like. And then we need to install Kubeflow. Installing Kubeflow is very easy. It's also very well documented in the Kubeflow website. We basically need to run these 4 commands and would be clear. I've already done these commands executed these commands in my cluster because it tends to take quite some time, 8 to 10 minutes. Sorry for that. And then after installing Kubeflow, we need to install Spark operator. To install the Spark operator, it's very easy also. We are using Helm. For those that don't know, Helm is a package, kind of a package manager for Kubernetes. And after installing the operator, we need to do some changes in the permissions that Spark has in our cluster. What we are doing here is creating a, let me find the file. We are creating a service account, and then we are creating a role that has some permissions. For example, it can create pods and delete pods and patch pods. And then we create a binding between the service account and the role. And the next step is optional. If you want to have easy access to the Kubeflow UI, you can create an ingress, or you can simply do the port forwarding for the pipeline UI service. I've already done that, and here is how the Kubeflow UI, Kubeflow Pipelines UI looks like. Then we can, after doing the setup, we can take a look at how our code looks like. Basically, this is it to how we can define a pipeline. We start with a pipeline decorator, and then here we load the manifest file. Here's we're just reading a YAML file and then updating the name of the job, adding some randomness with epoch, because we don't want all the jobs to have the same name. Then we load the apply component and feed in the job manifest. And then as the output, we get the name for the job. The next instruction is basically telling Kubeflow not to cache anything about this job, because we want, every time we run the job, we want to actually execute the job. We don't want to have any cache. And after submitting the job to the cluster, we are in the step where we want to get the status of the job. This is done using a graph component. Here, same story. We load the get component. We feed in the job name, the application name, and then we execute it. We add a bit of a sleep time here so that we don't do DDoS our control plane with requests. And then finally, we check, is our job in a completed state or not? If the state is not, we recursively call the function again, wait 5 seconds, and then check again. In order to be able to execute recursive calls, we need to add this graph component telling Kubeflow pipeline to allow this. And yeah, here we instruct Kubeflow that please check the status only after we have submitted the job. And when done, we create a print operation, basically printing a small message. And we tell the engine to execute the print message only after we are out of this loop. And again, here we remove the cache. And that would be it for the code. We run the pipeline. Here we are extracting, or we are generating the YAML file that we will upload into the Kubeflow UI. So, am I sharing the correct one?
Yep. Yeah, I see the
Okay.
Kubeflow UI. Yep.
Then here we upload the pipeline, select the file that we just generated. Would be this one. And create. Here we can see a visualization of the pipeline. Here we have the apply. And then here we have the loop where we get the status, we check our condition and so on. And then after we are done with the loop, then we print a message. Let's go ahead and create a run for this. We need to make sure that we use the service account with kind of elevated permissions here. And start. If we now go to our Kubernetes dashboard, we will see that things are moving here. The job is creating the first step. Here, I believe we are doing the kubectl apply. And here we can also see the status. Initializing pod now. And now we are done. Here we are spinning up the driver for the Spark job. In the meantime, our pipeline is also spinning up tasks where we check the status of the job. Here the driver is spinning up the executors, and the other tasks of the pipeline are kind of waiting till the job goes into the completed state. Here we can see the tries we're doing. It typically takes 1 minute, 1 minute 10. And yeah, the executors are still running. What this job is doing is calculating an approximation of pi. This is one of the examples provided by Spark. And here we can see that we went out of the loop because the job is now in the completed state, and we print a message that the job is completed. If we check the driver logs, we can see what's the estimated value of pi. In this case, it would be 314.57. Sometimes it's different. Right. If we try to execute this job without the special service account, we will see that we might fail because it does not have enough permissions to spin up Spark applications. Yeah, see, it's forbidden to run Spark applications for the default pipeline runner service account. Yep, that was it for the demo. To kind of summarize, today I spoke about Kubeflow, Kubernetes, Spark, and their integration. We learned what pipelines, components, and component specifications are. If you want to read more, feel free to check out the Kubeflow documentation, the Spark operator. Also, all the code that I presented today is available in GitHub. And if you want to shoot me an email, feel free to reach out. Oops.
Excellent. So really cool stuff. I've got a few questions for you, and feel free, anybody else who's in here, to ask a few questions if you would like. I know that a lot of people talk about how Spark is almost notorious for being a really heavy lift. And I'm wondering if you have any thoughts on that, like when a good time to use Spark would be, when it wouldn't be so good, or when it's overkill?
It's hard to have a hard cut. However, it's a trade-off. If you want to really do the big things or the actual, I don't know, production processing, gigabytes and terabytes of data, I think you'd have to go with Spark. But if your data does not go above 1 gigabyte or 2 gigabytes in volume, maybe that's an overkill. Sometimes the transformation with this amount of data can be done with either pandas or, I don't know, other frameworks. I agree. Spark is a hard lift.
Yeah.
But sometimes it's necessary.
Yeah, totally. So now I also want to ask you about integrating Kubeflow pipelines and this whole thing that you just showed us. Like, how would this work with a CI/CD pipeline or a CI/CD process?
The good thing about the Kubeflow pipelines is that everything is defined as a Python file. So you can manage these Python files the same way as that you manage other Python applications. Store these in your source version control of your choice and then deploy them as you see fit. Also, Kubeflow offers a nice API that you can call for if you want to update the pipeline, if you want to delete the pipeline, and so on.
Excellent. So there's a question coming through in the chat right now. Is there any relation of Hadoop clusters in this demo?
I'd say no. Here, the purpose of Kubeflow is to make everything run on Kubernetes. So this way, this is only one part of the workloads that are running in your cloud. You might have your applications, your front end that is consuming these models running also in the same cluster, and all the intra-communication between your tools is happening very fast. Everything is in the same cluster. And Hadoop here can be running on the same cluster, but it's not needed.
So can you give us a few use cases of when this would be useful?
Imagine you have all the pipelines feeding into your Snowflake cluster or Snowflake deployment. You have also some data coming in as JSON files, and then you're storing them into the data lake. And if you have a Kubernetes cluster with access to these data sources, you simply spin up a pipeline that can read the data sources and does the processing in the cluster. Theoretically, these clusters can have infinite processing power. That's, if it's realistic or not, that's a different question. But here you can expand as much as you need for the workload that you have at hand. If it's a small workload, you can also run it small.
With great power comes great responsibility. And
indeed.
So talk to me about how this compares, how like this solution compares to Argo CD.
I'll stop sharing. So with Argo, basically Kubeflow Pipelines is using Argo underneath. It adds a bit of machine learning context on top with serving, with training operators, but underneath is using Argo to orchestrate everything.
And I know that in the community, there are a few people that are opinionated on why Kubeflow does that, and it's so tightly coupled with a few different pieces. Do you or have you found other alternatives like this that could also work?
I took a brief look at Tekton. It has similar features as Kubeflow pipelines, and it's not coupled with Argo as far as I know. So Tekton might be an option. But now there are also some other commercial frameworks coming up. Nothing comes to mind, but for sure there are some things.
Yeah. And just for clarification, because I know when we're talking about Kubernetes, there's Tekton with a K and there's Tekton with a C. Which one were you talking about there?
Oh, with a K.
Okay, with a K.
Now I have to look it up.
With the feature store one or the one that's more related with Kubernetes?
The one that is more Kubernetes.
Okay, cool. Good clarification on that, because it's a little bit confusing sometimes. And so I know some people could get confused on that. Now, as far as like what you showed us, what would be some next steps? Like you showed us that. Let's say that we go through this demo and we plow through it. What else should we do? Like, what would you recommend us doing next after we've done that?
I think you learn when you have productive production workload, and implementing this example in your production case this is where I see the most benefit. You will see all the problems that might come up. I don't know, resource limitations, memory limitations, and then you need to play with all these parameters. But make sure not to spend too much money on your cluster.
Yeah, that's easy to let that happen with the infinite, as we said, the infinite scaling powers. What are some other things that we should watch out for? As you're mentioning, there's obviously the cost, and it can run away from us really quickly. But what are other things that we should potentially keep in mind as we're setting this up?
Yes, this would be more into the Spark direction. Sometimes the job seems to be very slow, but might be that there is a lot of communication overhead going on between the pods, and this might be slowing down the job. It's not the job itself. So try to make sure that your network overhead is not too much. Make sure that the logic kind of doesn't change the grouping of the data frames during the execution. Other than that, sometimes permissions can be an issue. The Spark operator needs some permissions to check or to be able to spin up pods. This is usually not how it's allowed, because you want to be the only one that can spin up pods, not some pod running in your cluster. So we need to be careful with that. Use a dedicated service account for that only.
Excellent, man. Well, this is awesome. I really appreciate you coming on here and showing us this. If there are no more questions from the gallery, I think we can end it there. This has been super helpful, and you make it look easy. I know from experience it is not as easy as you make it look. So
just to give a bit of background, I tried to do this 1 year ago, and it did not want to work. no matter how much I and my colleagues tried. Then I got some lightning one day, sat down and decided to make this work, no matter what it took. And yeah, finally it worked.
Well, because I know there's been a lot of updates on Spark, and obviously that Kubeflow is releasing new updates. I think it's every 90 days. Yeah. Did you notice, is it because of that, like the year of progress that both Spark and Kubeflow have had?
It was some releases on the operator. The Spark operator was a bit flaky at the time, and in this 1 year it got more stable and also a few improvements. Kubeflow started allowing the execution with a custom service account of the pipelines. This was 1 year back. This was not possible. Yeah, I think these are what helped most.
Is there only one Spark operator?
There are two. Two. I'm using the one that is developed by Google, but not supported by Google.
Okay. Yeah, that's good to know too, because that can be confusing sometimes. And when you talk about the Kubeflow pipelines, I know there's also, which I'm not familiar with, but maybe you have some experience with, like Rock and Kale. Have you messed around with that at all and trying to make this work with them?
Kale is something that can make your Jupyter notebooks run the Kubeflow pipelines. I did not mess with it, but that would be definitely in my to-do list at some point. With Rock, I don't have any experience.
Okay, nice. Cool. Well, this has been really awesome. I appreciate all of the knowledge and wisdom that you've shared with us, and look forward to chatting more. Everybody that's come in, we'll have Sadik send over the presentation for you, and look forward to seeing you all next week. Same place, same time.
Thank you for having me. It's been a pleasure.
No problem, Sadik. Thanks for doing this. We'll see you all later.